Hey guys, one of you asked me a question about the cost unit in the Postgres plan here. I made a mistake in the lecture and I incorrectly uh, referred to it as a millisecond, which is incorrect, right? And I want to correct that. So let's discuss that a little bit. All right, so this comes from Jasic. I'm sorry if I mispronounce your name. But the question is like in the video, you said that the cost unit is millisecond, but that's not true. He's right. According to Postgres, the unit is not in millisecond. It's just a unit defined by the database, right? And that's very critical. And I can agree with him because that I just made a mistake. I think I was thinking that it's a millisecond. It has nothing to do with a millisecond. It's just a cost. It's just a number. And so when we look at a plan, and it's a good example to go through another question here that Adam actually posted, where these costs are actually just values, right? And you might say, if it's not millisecond, then what it is? Does it really matter? Right? You can think of it as I/O, like the cost of I/O, right? But it's a unit, right? What matters is the higher the value, the higher the cost of the query. That's all what matters, right? But it doesn't really equal to the number of milliseconds, right? So if I see a value like 4.2 here, doesn't mean that it's gonna take 4 milliseconds. No. That's all. And I corrected the lecture for that part. Yeah, it just says it's gonna cost me 4 units of whatever this costs. Maybe it's the how many logical IOs I'm gonna do, how many CPU cycles is gonna take to process these things. So it's like a combination of things, and that is morphed into this unit. What we need to like is this is the first, as I said, like this is the cost to fetch the first row. This is the cost to fetch the last one, right? And that's what matters. But and the second part is like what it actually took me. So it took me way less, right? So that's part of the estimation versus the actual execution, right? If you see the estimation being way different than this, then we start looking at the statistics. Did we run vacuum or not? Or did we, like, are we up to date? Is the statistics, or did we run analyze? Is everything is up to date or not? So this is actually very critical. And he actually posted a link here to an article explaining this a little bit more. So I apologize for the mistake if that confused you. But yeah, again, as I said, the cost here is a unit. Doesn't matter what it is. The higher value, the higher the cost. The lower the cost. The first entry is the cost to get to the first row. You will see that if you do an order by, that initial value is going to be high because just before the Postgres gives you an answer, it has to sort, right? And the cost to sort is added on top of everything, like the cost of the I/O, not only I/O, the cost of the I/O to fetch the page, the cost of the CPU, like to calculate all this thing, and then it's added to the minimum value to get you that, right? All right, so to explain this, I wrote up 2 queries here, one with order by and one without order by. And I want you to notice this. The one without the order by, look at the cost. It's 0 because for each table, because I have partitions on this table, I'm doing select star from grades, right? So the cost to fetch the first row is 0. There is absolutely no cost because it's literally the first thing I'm gonna do, right? So yeah, what's happening here is you can see the cost is 0 here because we're reading all the partitions, and then finally we're gonna do an append, right? And return the first row. The cost to return the first row after reading all the partitions, probably not a good idea to do the partition because it's a little bit complex, but you guys get it, right? So the cost to get the first row off of all these partitions after we read all of them is 0. There's nothing, there's no cost because literally whatever the order that we got, just pick the first one, right? Which we have like a pointer to. So there's no cost to fetch the first one, right? The cost to get the last one is 21, right? But take this. With an order by on G, I said order by the grade. So here, again, if you notice that the cost to fetch the first rows here are 0. Why? Because we're not really technically ordering for each query on the partition. We're just reading it raw, right? But then after we appending all rows, the cost to append is nothing, right? To first fetch one. But the cost to append the last one that's the most cost. Then we apply the sort and look at that. The cost to give you the first row after the sort is 70. It's not 70 millisecond again, it's just 70 as a value here, right? So that's a higher value. That means, of course, 70 is greater than 0. And as a result, it's a lot, right? And the cost to give you the last after that is just 3 costs after that. So 73, right? So that's because we don't have much rows, but the cost to give you that. So that's, be very careful when we're having order by, because that is the cost to give you the first row, especially if you have like if you give a query, the latency is here. Like, what is the latency, especially if you're like fetching the first limit, like give me the first 1 row or 2 rows. Doesn't matter. If the planner has to do a query and has to sort, that cost has to be done first, then before the select, right? All right, guys, that's it for me today. Hope you enjoyed this lecture. I wanted to clarify that cost parameter and just hit it in the nail and correct my mistake. See you in the next one.